and the last thing we did yesterday was to see how we can converge the fiber channels and TCP. All right. So today we're going to start with network technology. Can you guys see my screen? Can anybody confirm if you guys can see my screen?
Yes, we can see your screen.
Okay, thank you very much. All right, so we'll start with network technologies. So when we're looking at all these technologies, we realize that it's all rely on the network. So if we don't have the right network, it doesn't matter how good your devices are, doesn't matter how good are your computing power, but your system is not going to perform well because of the network. All right, so the network are the basis for interconnection of all platforms and services. So a network is basically a principle of communication between different devices, right? So this can be uh, connecting. Your network can be a local network, or it's a network via the internet, um, using your Wi-Fi or your Ethernet. Um, so I'm sure you've heard the concept of an IP. So if anyone who's connected to the internet or to any type of network, the computer will reveal what we call an IP address. Whether it's a website, when you look at any website, behind the name of that website there's an IP address. So every website is as an IP address, which will actually lead to the server. So the IP address is just like an address of where the data are stored. So your device, as your phone or your computer, will have its own IP address, and the internet at which you connected, that router will have an IP address. So it's easy to track where is the connection coming from, where is the information coming from. So what is exactly uh, an IP address? You need to understand an IP address is just a unique address. So you can't have two devices with the same IP, right? So you can't have two devices with the same IP, because it's a unique logical address which is used to identify a device. Okay, it's used to identify a device that will send or receive data through a network. So that is a simple explanation of what is an IP address. So it's just a unique logical address which is used to identify devices that are sending or receiving data over the internet. So to the function of an IP address is just to identify the host. So where is the information coming from? Which device is using that, is releasing those information, and it's easy in a network to track where every information is coming from. So very important to note that the IP address will be unique, and the purpose is just to identify the devices and to enable the communication that are allowing all the data to be sent from a certain source to a certain destination. So we will have many type of IPs. So you have the IP v4, which use 32-bit, or you can have as well an IPv6, which will use, I think, 128-bit. So the IPv4 is what you see mostly. When you check a certain website, you will see the IP address there, or your computer. So the type of IP address that you see with the IP v4, you're gonna have, for example, an IP like, let me just try to see if I can write. Yeah, this is an example of that. You have maybe 192, 196. dot one or something. Trying to see if I can write. Okay, this is not allowing me to. Let me do this. Yeah, so this is the IP address. So you can see on a certain maybe website or your device, it's showing an IP of maybe 192.168. In this case, it's gonna be .10.1. So this is the IP address that we have, and this IP address will be unique. So this is an example of an IP v4 32-bit, which is written in 4 decimal numbers. So these are decimal numbers. So we have a total of 4 bytes. Okay, so these are decimal number. Obviously, decimal numbers from 0 to 9. Okay, these are decimal numbers. But behind that, there is a binary digit. Binary digit, like 192 is converted to this binary digit. 168 is converted to this one, and 10 is converted to this, and 1 is converted to this. So this is how we get a 32-bit. You need to understand, for you to get so 1 byte. How many bits is 1 byte, guys? How many bits is 1 byte?
Four. No, eight.
8. Yes, 8. So you can see here. So we need that's why we're having 8 bits here. So we have 8, 8, 8, 8. So these are 32 bits. So this is converted into binary digit. So from decimal digit to binary digit. So in binary digit, we have 32 bits. So these 32 bits now here is the, the binary digit in terms of the IP address. So this IP address here can be also represented as this. Okay, so now when we have the type, like for example, the IP v6, which will need a 128 bit, that one will be written in hexadecimal. So the hexadecimal digit is when you will have numbers and letters at the same time. All right. So you have, for example, um, for 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 hexadecimal, you have numbers and letters that represent a certain value. Okay, so binary goes from 0 to 9, and then you have not binary, um, um, decimal, and then you have binary, and then you can have hexadecimal. All right, so um, this is just how we get to get the what you call this, the 192, for example, when we're trying to converting decimal to binary. So basically, we have uh, the first. So we have each position where we're going to have your. So here we have 192. So 192, we're going to have this is converting from binary to decimal. So this is the binary digit that we have. So this is the decimal number. Okay, so now there will be a difference between an IP address and what we call a MAC address. Because when you look on your router, for example, you have you have a MAC address. So the MAC address is an address which is actually burned into the device. So each device will already come with the MAC address. So the MAC address is not related to the network, it's related to the device. So your router will have its own MAC address, or your computer will have its own MAC address. But your IP address can change and be reassigned depending on which network you're connected to. So your IP address is not something that is permanent. It's something that can change. So because the IP address comes with an information about the network you're using, but the MAC address, you need to remember, it's going to be a number that does not change. All right. So there is many structures. This is the structure of the IP, how the IP is structured. So basically, when you look at the IP address itself, so you have a portion that will represent the network, and the other one represents the host. The host is the user. The host can be the computer or the phone, something like that. And then you have a subnet mask, which will specify which portion of the address refer to the subnet and which portion refer to the host. So in this case, we have this. So this portion here will refer to the host, which in this case is only 1. So in decimal, we're going to have 1. When you convert 1 to binary, you also get 1 here, 0, 0, 1. So this will be an example of an IP address. So this part here is the network portion, and this other part is the host portion. So there is many IP classes. So the IP classes are just classes, though that means the IP will be classified into 5 classes. So we're going to have the 5 classes from class A to class E. So the 5 classes will help us, will facilitate the IP address management and networking in terms of how the IP is being used. So the easiest way to determine the class of an IP address is just to check the first bit in the network bit. So in the network portion, you look at the first bit. Like in this case, we have 0, this. So this is what we have. So that's how we're going to classify that. So we check the first bit of its network bit. So the class field of A, B, C, and D, and E, right? These are the 5 class. These will be binary numbers. So you have the 0, 10, 0, 10, 1, 10, 11, 10, and 11, 11. All right. So class A, B, and C will just be what we will call and will be an assigned to the host, right? And then D and E will be used for multicast or for research. So basically, your D will be multicast IP address. Your E will also be like for research or for experimental. So your E is just an experimental, and then your D is just for multicast. All right. So this now looking at this section, we're going to focus on a network that are using class A, class B, and class C. Okay. So when you have a network that is using class A, that type of network will be called a class A network. If you use class B, it's a class B network. If you use class C, it's a class C network. All right. So looking at that, so basically for you to understand that better, so very important to note that class A, B, and C are what we call the unicast addresses, which are assigned to the host. And then we have class D, which is the multicast addresses. And then we have class E, which is just an experimental, which is done just for research. This is a type of IP that is reserved. It's not for general use. Okay, so when we're looking at some of a class A, so okay, so in a class A, we're going to have a certain range of, uh, of IPs. You have maybe an IP with maybe 0000 to maybe 127 something, and then the type of network, the network bit, it's usually like a 8-bit network, right? So this can be used for also very large network, you know. And then you have your class B, which has a certain range as well. Class C has a certain range as well. So a class B can be used for just medium-sized network, and a class C is for small networks. Okay, so all these IP addresses will depend on what you're trying to use them for. Okay, so remember in the term we've been using when we talk about a host, what we mean by a host is any device with an IP address. That can be a computer, a router, a phone, or any type of device. Okay, and then let's talk about the concept of public and private IP addresses. So when we talk about public addresses, so the public addresses are assigned by the Internet Corporation for when you have what you call that. Um, so they are assigned by the Internet Corporation for assigned names and numbers, which is called the ICANN. So this is just to ensure that each IP address is unique on the internet. So when you have a website, that website will have a unique address, which is an IP address. Okay, so to make sure that these IP are assigned as a unique number, so you have the Internet Corporation for assigned names and numbers that will provide that IP address. All right, so that's for public address. And now when we talk about private, private IP address, so you need to know that some networks do not need to connect to the internet, right? So for example, if you are building an app on your computer, you are offline, you're building an app, but as you are testing certain part of your app, so you need to use a certain server, using your computer as a server, you have your private IP address, which you can use locally. You don't need the internet. So your computer will have a private IP address that we're going to be using to test your app and everything. And then when you are ready now to deploy your app live, then you're going to look for the public IP, which is maybe for the server where you want to upload it. All right. So some network do not need to connect to the internet. So if you have your network in a closed lab, for example, at university, there's no need for the internet. It's just a network inside the lab. Okay, so we can have an IP address for that network for all the devices in the lab, which will be a unique ID. Uh, so that's why some of the class A, class B, and class C IP addresses will be actually reserved for this kind of situation. So these are what they call private IP addresses. So you can have class A, B, or C of this. So you have an organization where you can have this. Okay, so public note that the public IP addresses are assigned by the ICANN, Internet Corporation of for assigned names and numbers. So the purpose is to ensure that every device on the internet has a unique IP address. So this will allow all the devices to communicate directly over the internet. This an example of devices where you can get this IP, your home router, you have your modem. These usually use public IP that are assigned by the ISP. Okay, so your private IP address, this will be reserved for the use within a private network. No need for the internet when we talk about the private IP address. So this will just allow devices from a certain local network to communicate uh, amongst themselves without having to connect to the internet. So this type of IPs are used in, we can use in your home, in schools, offices, labs, you know. So no need for the internet. So um, certain private IP ranges are reserved for that, and these are the examples. Okay. Okay, so you need to note, very important note is that devices in a private IPs cannot directly access the internet. Okay, they cannot just access the internet. Why? Because of the type of 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 um, of the network address translation that is being used. So in this case, you use the NAT. So the NAT, network address translation, that is being used. So when you are on a private network, for you to access the internet, the problem is that you need the NAT on the router or the firewall to map your private IP to a public IP. So that's the problem. So that's why you can't just access from a private to public because of the NAT. Okay, so and then we have public IPs, private IPs, and we can also have what we call special IPs. So these there are some special IP addresses that have special meaning and functions, right? So these special IPs will actually uh, address certain so basically an IP address that is will be used just for a limited broadcast of certain information. Okay, so these IPs, for example, you have this the limited broadcast address. So you have this type of IPs. So in this case, the function will be we have packets that use the address as the destination address. Um, this will be sent to all hosts on the same network. So it means that the information can only go to these devices on the network. So these devices will have this special, like a broadcast address. So only these devices with this will get this information. So, so this address is called a limited broadcast address and can be used as a destination IP address of an IP packet. So after receiving an IP packet whose destination IP address is limited to just that broadcast address, a router will stop forwarding the IP packet. So certain information need to be sent, but they are sent on the network, but they can only reach certain computers. So if this address is used as a network address, like the host address will be what we're gonna refer as the interface IP address. So the host address will receive the information. So this information can only be shared in a certain with limited uh, devices, so limited host. So this is just used for broadcasting a packet. When we're talking about broadcasting a packet, is certain information to all hosts in the same local network. So the routers do not forward these packets outside of the local network. So it's gonna be limited to that. Okay, so we have this. These are the limited broadcast address, and then we have any address. Any address, you have the IP 000. So this address is the network address of any network, or the IP address of interface on a network. So this is usually when you're creating an app, and now you don't know which one is the IP address of your computer for you to test the app, and you're struggling to find the server and anything, so you can just let the app look for the IP00 because it's gonna take any network. All right, so that's how you can actually do that. So the as a network address, so the 000 is called the default root, which is the any network. So as a host address, so this 00 will just represent the host, any host. Don't have to assign it to anything, so it can be any network. All right, and then you have the loopback address, which would be a 127.0.0 and then /8. So this address is just used to test the software system on a device. So when you're checking on a device, you can use this to test the software. Okay, so that's the and another term. Can anybody tell us another term how we call this IP address? Anybody knows how you call it?
It's localhost.
Sorry.
Localhost.
Perfect, perfect. That's what we call local host. So this is the local host. All right, so that's your local host. So the purpose is just to test internal network stacks on the device. So you have your internal communication on the device. All right, so whatever is sent or whatever packet is sent in this network does not leave your device. It stays in your device. So you're testing a certain page, everything is happening in a device, so you can't, yeah. All right, so, and then you have the last one, which is the link local address, which has this format. So the link local address will be this type here. So when the host failed to obtain the IP address automatically, the host can use the link address for temporary communication. So this is just for temporary communication. All right. All right. So now we will have to. So there is a way. There is a way that these IPs are being calculated. There is a way of calculating an IP. So you have what we call a subnet mask. So the subnet mask are actually used to calculate the network address or the network ID, right? It calculates the network ID. Remember, we have the network ID and the host address, and then both of them create the IP address. So the IP address does not just have a network address; it also have the host address. So the host address together with the network address that create an IP address. So now you have this subnet mask that's are used to calculate that. Okay, so this is an example here, and then each bit of the host ID will be one, and then this is how it's going to be to calculate that. So when we look at an address like this one here, so the subnet mask will be uh, maybe a value of 255.255.255.0, and then you have a network ID as well, and then you have an host ID. So the network ID will be maybe this part here, and then you have the host ID. Yeah. Okay. So, so the subnets mask will tell us which part of the network which part of the IP is the network and which part is the host. And then you have the broadcast address, which is used to for as a special destination address to send data to the host on the network. So what does it mean? It means that the broadcast address is just to address where all host bits are set to 1. So this is used to send a message to all devices in that subnet. And then you have your available address, which is assigned to a node or an interface of devices network. So the available host, these are usable IP addresses for devices only. So some of the rules that you need to note is that you cannot use the network address as 0000 or the broadcast address of all values are like 1. So in the network address, all values cannot be 0. In the broadcast address, all values cannot be 1. Okay, so so this is how these are calculated. So the numbers of so we have something like this where the network address and the broadcast address cannot be used as the address node, and then the numbers of available IP address on a network segment is calculated as 2 to the power n minus 2, and n will represent the numbers of host bits. Okay, so an example can be, let's say we have an IP address. Let me see if we have an example here. Okay, so we're looking at this. We're trying to calculate the IP address. Let me just look at another example. We have 192.1.0/24. Let's say this is our IP address. So when we look at this now, the subnet mask for 8 bits will be, for example, 255.255.255.0. So the total address in this case now, we're going to take, remember the formula is 2 to the power n minus 2. So 2 to the power n, the n will be the numbers of, as we've said here, so the n will be the numbers of host bits. So in this case, in our case, numbers of host bits, let's say we have, what is that? We have 8. Let me see. So we have, so the numbers of host bits, okay? So we're dealing with 8 bits per decimal digit. So it's a 8 host bit. So because it's the 8 host bits, so we're going to take 2 to the power 8, which is 256 minus 2. That will be a 254. So now this IP address here will be in a range of 192.196.1, and then remember we said there is one rule here, the available address. So here we need to make sure that we never get the values, all the values of 0. So what we're going to have here, we're going to have this range here. So from this number with a 1 there up to the same number. So we have from 1 to 254, because 254 is what we have as the 2 to the power n minus 1. Okay, so that's how. But we're gonna take more, I think, more examples tomorrow, and then we're gonna see how we do that. So that's how the IP address is basically calculated. So why do we need okay, so why do we need what you call this? Why do we need subnetting, right? Why do we need subnetting? Because we the variable length. Let me just something. So let's say you are given a class C, right? So a class C will have a default of 24. So we have 201, for example, 222.5.0. Okay, and then slash 24. All right, so so when we're looking at of subnetting, so when we're looking at subnetting is the process that we are actually using to calculate the the IP. So to see how, like in this case, we have this as a subnet address, and we can easily use it to get the available host address. Okay, so based on this is what we had. Now we have now to calculate this, we need to see the host. How many bits does the host has? So we go through all the calculations to see how many subnet we have. In this case, in this example, we will assign a class C IP address, this one, and then we assume that 20 subnets are required, and each subnet contains five hosts. So that's how we're gonna take it. So if we take each one will have 5 hosts, so each one will have 5 hosts. So the hosts, we have a 5 bits, which is a 5 bits available. So 5 bits, it means no, not 5 bit, 8 bits. So we're gonna have to choose the subnet. We need to choose something that we have, let's say, 2 to the power something, which needs to be greater or equal 20, because here we assume we have 20 subnet, right? So if we take 2 to the power, so the smallest we can get, because if we have 2 to the power 4, 2 to the power 4 will give us 16. So the smallest we can get for that is 2 to the power 5, which is 32, which is greater than 20. So that's why the smallest we can get in this IP address will be using 5. So the smallest 5. So if we have 5, that will give us about 32 subnet. Okay. So there is a few calculations that need to be done for us to get to this. Tomorrow, that's the first thing that we're going to do. And then we will understand it better, how you do all these calculations. All right. Is any question? Any question, guys? All right, guys, just to summarize there, just understand the IP address is just a logical address for any devices connected to the network. One part of the IP address is giving information about the network. The other part is giving the information about the host. And what is the host? The host can be a computer or any type of devices. Okay. What is the subnet mask? The subnet mask will separate the network ID and the host ID. All right. And what is the broadcast address? The broadcast address is the address where all host bits are set to 1. Okay. What else do you have to remember as okay, that we have special addresses. Some are limited broadcast addresses. Some are the any network, which are the default routes, which are used mostly when you are using your local, but you don't want the computer to be based on a certain specific server, but you want to use any network. You have that, and then you have your loopback. Your loopback is what we also call a local host, which is used just for you on your device if you are working maybe on a software locally. All right. So those are the type of special IP addresses, and we also spoke about different type of IP addresses. We have 5 classes from class A to class E, and class A to C are unicast IP addresses, and then you have your class D, which is a multi-class, and then multicast, and then you have class E, which is just for experimental purpose or for research. And note that every IP address on public IP addresses is assigned by the ICANN, which is the Internet Corporation for Assigned Names and Numbers. Why they assign that? To make sure that every device on the internet has a unique IP address. All right, so to avoid any type of duplication. All right, guys, and then you have your private IP address. Your private IP address is related to you creating this IP and address, which is local, no need to connect to the internet. All right, guys, that's it for today.
Sorry.
Yes.
I have a question. Is the broadcast address and the multicast address the same thing?
What you're saying?
I'm asking if a multicast address and a broadcast address is the same thing.
No. It's not the same thing. When you talk about broadcast address, so the broadcast address, wait, you're asking between broadcast address and multi when we talk about multicast?
Yes.
No. So it's they are not the same, but we can say they are concepts that are related. It will depend on how they are designed, but they are different, completely different. So what does it mean when we talk about the broadcast address? So the broadcast address is just an address which we use for in a network. Remember, we even say all the host, which is the last numbers, are assigned maybe a value of 1. So a broadcast address would just be an address which is used to send certain data or messages to all the devices on a network. So there will be a specific network where we have certain hosts. Remember, let's say your network IP. Let me just write somewhere. Okay. Okay. Let's say your IP is this one here. Okay, this is your IP. This one. This is the network IP. But now what you do is that you create certain hosts on the network, which will have maybe an IP with maybe at the end there is maybe a 2.55. So all 255 hosts in this subnet that you created will receive this information, but not all the computers in this network. You understand? So this is kind of creating a limited local network. Okay, that's for the broadcast address. So the broadcast address, you create a certain IP, and certain devices will connect. Only certain devices will connect to that IP, and you send that information to that IP only, right? Now, for the broadcast, it goes to the whole. It's kind of a one-to-all communication. So you send from one computer to all the computers in a certain subnet. So if all your IPs, you have the first computer, which is maybe 25, not 25. We have 1, 2, 3, up to 255. So all the 254 hosts will receive those messages from the broadcast address. But now a multicast address will be an address that we're going to use to send a certain information to a specific group of hosts only. So you put a certain range, so you have a specific group only people. So if you have, let's say you have a company, let's say you are in a lab, and in the lab there is 100 computers. And remember, all these computers are first connected to the same network. That means the first part of the IP is the same, and then the last part of the IP, which determines the host each computer, will be different. So if you have 100 computers, this information in a broadcast address will go to everyone in the network. But if you use a multicast address, in this case, you're going to determine the range. So this information will go from the computer where you're sending the information to specific groups of computers. Maybe you only want to take it from IP1 to IP50, not IP100. Do you understand the difference?
Yeah, I understand.
Yes, so that's the difference. So the multicast, you are sending to multiple devices, but not all the devices in the network. But a broadcast will go to all the devices in the network. You understand? So that's the difference. So for broadcast, everyone on the sub network will receive those information, but for the multicast, it's just a specific group of devices that will receive it. All right, guys. Yeah, that's it for today. For those who can turn on the camera, you can turn on so we can take a attendance screenshot.